Hey guys, here we are again with 8.2 in our going through chapter 8 in our Big Ideas curriculum. We were just talking about similar figures in 8.1, and here we're proving triangle similarity with a theorem, and it's the AA theorem. So if you remember back a little ways, we were proving triangle congruence earlier in last semester. And we had several different congruent theorems there, like I think we had about 5 of them. And we had side, 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 which we said SSS, and side, angle, side, and those kind. And we said there was no triple A. There was no angle, angle, angle theorem. But we do see one here with similarity with just angle, angle. And that's what we're going to look at today with angle, angle similarity theorem. We'll look at a real-life problem here towards the end, which will actually be on your quiz. So as we get started, let's look at a little Calvin and Hobbes cartoon. So they're in a little, it's like a wagon going to be pushed down the hill. There's a new girl in our class. Well, what's her name? Who knows? Is she nice? Who cares? Not me. Do you like her? No! Calvin and Hobbes is one of my favorites. All right, so getting into just that theorem about angle, angle, similarity theorem. So basically, if we have 2 angles in one triangle that are congruent to 2 angles in a similar triangle, or just in even another triangle, not necessarily we don't know they're similar yet, then we can say they're similar. So that's what it's saying here. If angle A is congruent to angle D and B is congruent to E, then we can say that the triangle ABC is similar to, so that's what this little symbol means again, is similar to triangle DEF. And so that's what we're looking at. If we just see and show that 2 angles in one triangle are congruent to 2 angles in another triangle, then we know those triangles are similar, which they would have all the characteristics, which we know all the angles would be congruent. So we could then say if these are similar, then these angles are also congruent, and all the sides would be proportional then to say that they're similar. Okay, so here's an example in the book, but we'll just look at this really quick. And just says determine whether the triangles are similar and explain your reasoning, basically. And we can see from this, we got angle D and angle G. Those 2 are already showing that they're congruent. So they're right angles. We know those 2 are congruent so far. We got a 26 for C up here, a 64 for H. So what we could use is we can use a triangle sum theorem on one of these triangles. It doesn't matter which one. They're going to do it for this smaller one. So that's the first thing they're going to say is D is congruent to G. And now we can use the triangle sum theorem where we add them all up and set it equal to 180. So we say 26 plus 90 plus the angle E of this smaller one equals to 180. And we can then figure that out. If we add 26 and 90, that's going to be 116, and subtract that from 180. We can figure out that angle E is 64 degrees, which is the same as this angle H. So now we have E and H also congruent, and that would be 2 angles in one triangle congruent to 2 angles in the other triangle. And so then we can say that those 2 triangles are similar. So yes, they are, and the reason is by the AA similarity theorem. Okay, so there on page 229, the extra practice starts. So number 1 and 2 are just like that problem I was showing you, and you can just stop the video and pause it here. Try these 2 problems and see if you can get this right, determine whether the triangles are similar, and if they are, write a similarity statement and explain your reasoning. So if you can try to do that and then play it again and then see if you are correct and just fix anything if you made a mistake. Okay, so hopefully now you've paused the video and you're now checking your answers. So for this one on number 1, again we're told that we have a right angle on A and a right angle on E. So just there is one angle already that we know is congruent right there. So we want to use that triangle sum theorem on one of these triangles. It doesn't matter which one. So I'm going to use it on the smaller one up here with a 15. So I got 90 plus 15 plus the measure of angle C. That'll equal 180. And then if I just add those together, I get 105. And so I get 105 plus measure of angle C is equal to 180. Subtract 105, So 180 minus 105, that does give me 75, which is the same angle as D on this other triangle. So now that we have C and D also showing congruent, we have two angles from one triangle congruent to two angles on the other. So yes, these are congruent. So we can write our similarity statement. I'm sorry, not congruent, similar. Yes, these are similar. The angles were congruent, so the triangles are now similar, and that's your little similar little sign there. So triangle ABC is similar to EFD. And then we want to look at why. What's the reason? The reason is just by the AA similarity theorem. Okay, on 2, we want to look at 30 degrees. That's one angle that's already showing congruence. And then we can do that triangle sum theorem again with one of these. It doesn't matter which one. It'll probably be easier to do it maybe with 2, or not 2, with the top one up here, the DEF triangle. Actually, no, I'm doing it with the bottom one. Sorry. It doesn't matter which one. You could have done it with the top one. So angle A, measure of angle A plus 116, which is here on B, plus the 30 equal to 180. So I'm adding those together, and that's going to be then measure of angle A plus 146. We're going to subtract now 146 from both sides. So 180 minus 146 is 34 degrees. So if this A is 34 degrees and that one's 44, they don't match up. So that means that this is definitely not going to be, two angles are not going to be the same as the other two. So this one is not similar on this one. If we tried to figure out what E was, it's not going to be 116 either. So we'll notice that even though that F and C were the same, E and D were not the same as A and B. Okay, here's another example from the book. Just take a look at this. Show that the two triangles are similar. And this gives you a similarity statement. So we want to actually explain and show this. So the first thing we'll notice is that this is kind of like one triangle kind of on top of the other. They're sharing the same angle A up here. So angle A is actually the same angle in both triangles. So first of all, because of the reflexive property, angle A is congruent to angle A. So right there you know that that's one angle that's congruent in both triangles. And you also now have this angle here, the 52, and C down here is 52. There's another one. So right off the bat we can just see, because of that, it's the AA similarity theorem again. That's why it's similar. On this letter B, we can see that these are parallel. It's showing us the parallel marks with the little arrows. That tells us it's always parallel. And we have kind of an X situation here, so that's creating vertical angles, and vertical angles are always congruent. So right there we know these two angles are going to be congruent. So we can do that first. We can state, because of vertical angle congruence theorem, we know that the angle here on each side of this V is going to be congruent. So that's what it's saying there. SVR is congruent to UVT. That's these two. And then also we can say that angle S is congruent to angle U because of alternate interior angles theorem, because this would be basically a transversal with these parallel lines. And so we have from chapter 3 that theorem, alternate interior angles. We use that one a lot in figures. It's often one used when we see parallel lines. And so that's where you can see these two are congruent, these two are congruent, and so yes, they are because of the AA similarity theorem again. Okay, so again, I'll have you try 3 and 4 here on the extra practice, just like that last couple problems we just saw. You're just going to show that the two triangles are congruent. So go ahead and pause the video again, and then do these two problems, and then play it again to see if you're correct. Okay, so you should be back now with those two problems done. And for number 3, this one's similar to that other one we saw where it was sharing this angle C here. So this one is on top of the bigger one. So they both have the same angle of C up here, which is going to be a reflexive property again. That'll be equal to itself. So angle C is congruent to angle C because of reflexive property. And then another angle that we can see that is congruent, because you see these parallel lines right here with the parallel marks. If these are parallel, then this actually can act as your transversal here, and what you would have would be corresponding angles. And that's what you need to remember from chapter 3 on this one. So you have a corresponding angle situation right there, and that would make the second one congruent. So now we have two angles from one triangle congruent to two angles to another triangle, so that you can say that they are similar. So triangle ACE is similar to triangle BCD by the AA similarity theorem again. On 4, what we see here is opposite sides are parallel, which would give us a parallelogram that we just saw in that last chapter. And what we remember from any parallelogram is opposite angles are congruent. So we can start off by just saying angle P and angle R, those are congruent because of the parallelogram. Opposite angles are congruent in a parallelogram. And then this right here, this diagonal from S to Q, would be considered a transversal because of the parallel lines here. And so again, with alternate interior angles, we can also see some congruent ones. So those alternate interior angles are congruent. So we can then show that PSQ, this angle right there, is congruent to RQS, this one here, because of the alternate interior angles congruent theorem. And so now that we have two angles from one triangle congruent to two angles to another triangle, we can say they're similar by the AA similarity theorem again. So triangle PQS is similar to triangle RSQ. All right, so here we are with the joke of the day. What do you call a rabbit who is really cool? A hip hopper. All right. Okay, here we are on page 230, 5 to 13. It shows us this diagram right here. It wants us to complete the statement. So in this diagram, we see these two lines here. They're not saying that they're parallel, but we can conclude they are because they both have right angles here. So basically this line right here is perpendicular to both of these. So if that's true, we know that these are parallel. And there's a few other things we could conclude from this. We can conclude some similar triangles within here. We have some vertical angles, and so you already see this angle here and this angle here are both right angles. Because of vertical angles, we know these two are similar triangles. If this is 90 degrees on this side, then we know it's 90 degrees on the other side. So we could do the same thing with these two triangles as well. So we definitely see some things that are true about this. So let's get into what it says here for 5. We're going to find the measure of AGB. So AGB, what is this measure right here? We're trying to look for what the measure of the angle of AGB is. So with that one, you would just use the 90, the 63, and then use triangle sum theorem to figure out this angle. That's pretty easy to do. That's just going to be 27 degrees. So you can think of it, well, really just if this is 90, then basically 63, if you say 90 minus 63, that would give you the 27 degrees there for this other angle. Now the measure of EGD. So EGD on this side, so now we've just found this angle, now we're looking for this one. Well, like I said, those are vertical angles. They're going to be already congruent, so we know that's the same thing. That's also 27 degrees. Then we're looking for the measure of BCG. So B and then CG. So we're looking for this measure over here. Okay, so that's going to be the same measure. So if we have, these measures are going to be the same here. We're going to see this is going to be still the same here because these are all similar triangles, like I said. We could see that these are similar, these are going to be similar to each other. So these are all similar triangles. We're going to see that this is 63, this is going to be 63 also here. Oops, as well. Oops, lost it. Yep. Sorry about that. Had a little glitch. Now we're looking for side AG. So side AG from here to here, we're trying to figure out, okay, what side length that would be. Now this one's going to take a little more time. We have a right triangle. In right triangles, we can always use the Pythagorean theorem to find side lengths. So what we do know is we know some side lengths here. We know that we're looking for A to G here on this one. So this is 3 on this side. It's going to be also 3 for AB. So we know that's 3. This is 6 from B to G. So using this right here as a hypotenuse, that would be like our c squared. So a squared plus b squared can equal c squared. That's what we're going to start to do here. Oops. Not sure what happened there. Aha. There we go. Sorry, got it mixed up a little bit. All right, so here we are. So a squared plus b squared equals c squared. That's whenever we were trying to find the Pythagorean theorem, we're looking for a missing side length on our right triangle. That's what we would use. And so we know what the a and the b is. The a is going to be 3 because it's going to be the same as this side over here. The b can be 6. So we just plug those in, 6 squared plus 3 squared, and it doesn't matter. Actually, I used 6 for a and 3 for b. That doesn't make any difference. We're going to still add them together. So we're going to see 36 plus 9 there. 36 plus 9, that's going to give us 45, is equal to c squared. So now to get rid of this square, to just find c, we got to take the square root of both sides, because that's what we're really looking for, is just what the side length is. So we take the square root of both sides, and the square root of 45 then is c. That could be our answer, but we probably want to simplify that. There is a perfect square in 45. That would be 9. So 9 times 5, and so the square root of 9 is 3. So the best answer for this one's going to be 3 square root of 5 then for number 8. Finding AB, well, we already kind of found that because we needed to use that. Maybe they should have put that one first, but that's going to be 3 because that's going to be the same as this side over here. FE, we're looking for FE on this one right here. So if this whole thing is 3, then we know that FE is going to be half. Each of these are going to be also congruent to each other. These are going to be the same. So they're going to be half of each other. So it's just going to be a 1.5 or 3 over 2 as a fraction. For ED, it'll be the same exact thing. That'll be also 3 over 2 or 1.5. And then for GF, so GF is going to be this piece right here. So there's another one we're going to have to use the Pythagorean theorem to find. So if we know that this is 3 and this is 1.5, that's what we'll use for our A and B, and we're going to find that C right there. So using those numbers, we're going to see 3 squared plus 3 over 2 squared is equal to C squared. So this will be 9. This will actually be 9 over 4 when we square top and bottom. So we're going to square top and bottom of that. So it's going to be 9 plus 9 over 4. I really should have put that in a parenthesis, that fraction, because you're going to square the top and square the bottom for 9/4. Now we have to add these together, so we probably want to get a common denominator to add those together, which would be 4 in this case. So 36 divided by 4 is 9. So that way we can say 36 over 4 is the same as 9, and now we can add these together. 36 plus 9 on the top. That's going to give us 45 over 4 is equal to our C squared. And now we can take the square root of both sides again like we did before. Now the square root of, we want to take the square root separately of each one. Square root of 45 on top, the square root of 4 on the bottom. We know the square root of 4 is 2. That's good. We need that to become a whole number. You can never have a radical over the denominator in your answer. So we'll have 2 on the bottom, and then that same thing, 3 square root of 5 will actually be on the top because we're going to have the square root of 45 on the top. So we'll have that 3 square root of 5 over 2. So that's going to be our answer for the GF. And then it's just going to say triangle AGC is similar to, so AGC, this whole triangle here is actually similar to this triangle here as well. And we could know that just because we got some angles that are all congruent in here. So we have this angle here is congruent to each other. We can see these are going to be congruent to each other, 43, because right there we could see that that's going to be alternate interior angles would make those congruent. So we know this big triangle is congruent to the smaller one. And so we'll just call that one DGF. Alright, so moving on to those last two problems. We're almost done. Okay, well number 14 is actually referencing that diagram that we were just using from 5 to 13. And it says write similarity statements for each triangle similar to the triangle EFG, which is this one here, EFG, this top little triangle right there. So, you know, what's similar to that? And we've already talked about that. We know this triangle is similar to this triangle here, so we could say that first. And we also know that this triangle is going to be similar to the other one on this side. and it's also similar to this one on this side. So it's similar to these other three smaller triangles here. So we'll just put that in as similarity statements, three similarity statements, because it's similar to three of these triangles. So the EFG is similar to EDG. That would be this other one on this side. It's similar to BAG, so that's the BAG up here, and it's also similar to BCG. So BCG, this one down here. For 15, it says determine if it is possible for triangle HJK and triangle PQR to be similar. And it explains your reasoning. So it gives you some information about these triangles. So the measure of H is 100, the measure of K is 46. So these are two angles from this first triangle, and then it gives you two angles from this triangle here, so it's giving you 44 and 46. So far we can see that we got Q and K the same. So if we can somehow show that we have, this last one similar, then we can do that. So we know that H is 100 and P is 44. So if we could show somehow that the third angle of this one is 44, or the third angle of this one is 100, that would then show that they're similar. So that's what we're going to do here. I'm just going to start with this triangle. I'm going to look at this triangle here and find the third angle, which would be angle J in this case, and see what angle that would be. So I'm going to use my triangle sum theorem. So I'm going to add these two together. It's going to be 146. And we're going to say 180 minus 146 then would give us that third angle of J, and that's 34. And since that is not the same as 44, then these are not similar. So they are not similar triangles. So we say no, measure of angle J is 34 degrees, so triangles cannot have two congruent pairs of angles then. Okay, actually I want to do one more problem, and this next problem is kind of a real life problem using this. And this next problem is going to be on the next quiz that you're going to take. So I wanted to show you this one. It's one that has talking about a flagpole. So a flagpole casts a shadow that is 50 feet long. So here's our flagpole, the shadow of the flagpole. We can measure that and figure out, okay, that's 50 feet long if we were to measure it. At the same time, a woman standing nearby who is 5 feet 4 inches tall casts a shadow that is 40 inches long. Okay, so we can measure how high she is or how tall she is, and we also can measure her shadow and figure out that's 40 inches long. We want to figure out how tall is the flagpole to the nearest foot. So that's going to take a long tape measure to try to figure out the length of that. So we can do this with this similarity, similar triangles in the geometry that we're doing. So we're going to make two similar triangles, one from the woman here and one from the flagpole and its shadow. So let's just go down to looking at solving the problem here. And so here's those two triangles that we can do. We can see, okay, the woman is 5 feet 4 inches, her shadow is 40 inches long. We can then kind of make a right triangle out of that and make it, that's the smaller triangle. Here's the flagpole. We don't know what that is, so it's the X. We do know the shadow is 50 feet long, and so we can do that as well. Now, she's 40 inches long and 50 feet long, so that's a problem right there. We would need this to be in the same measure. So we want to see about that. So it says you can use a proportion to find the height, which is X. We want to write 5 feet 4 inches as 64 inches. That's what this would be. So that you can form two ratios of feet to inches then. And so we have the X on the top here. So we see X and then the 50. So we have this one from the flagpole on the top, and we have the woman basically on the bottom here. She's 64 inches, and so we have inches to feet. So we just solve the proportion, okay, cross cancel or cross multiply here, so you can see 40x and then 3,200 divide by 40. That means x is 80, so that would give us 80 feet then for the flagpole. So the flagpole is 80 feet. All right, so that concludes 8.2's lesson, and you want to go on to the assignment for that, and I'll see you in class.